So this next section is applied electrochemistry. So we're just going to be learning about the different batteries that we may use in everyday life, everything from the car battery to the alkaline dry cell that you would see in like flashlights, or the lithium ion battery that you have in your cell phone or laptop. And we're going to talk about these different applications that you use. The theory is exactly the same that we talked about in our part 3 in electrochemical cells. So these are just different applications. So it's a pretty short section. So we'll start off with the lead acid storage battery. So called the lead acid storage battery because you have lead as at the anode, and then the cathode is a lead oxide, or lead 4 oxide plate. The electrolyte H2SO4. So a lot of your questions on your quizzes and tests are going to ask about the electrolyte in the lead acid storage battery. So you have lead and H2SO4, which is your sulfuric acid in it. So this lead acid storage battery has been around for a long time. 12-volt battery. It's in vehicles. It can be recharged by the alternator. The cons are it's heavy. It's made of lead. Here's the overall redox reaction we have, right? And we're producing energy as we see. The electrical energy is produced, and the charging reaction, you actually forcing electrical energy back in it, and that would be done by an alternator on the next page. So problems with this is the PbSO4 can flake off of the electrodes and fall to the bottom of the H2O4 bath. Eventually, new battery may be required. So, like, I think 10 years is probably the max life of a lead acid storage battery. Here's how it's hooked up in your car. So you have the lead acid battery here. Powers everything from starting your engine to the music to indicators to the windshield wipers. Alkaline dry cell. So this is like your Duracell or Energizer battery. KOH is the electrolyte. So a lot of them, they're going to be talking about the electrolyte. That's how a lot of questions you'll see. So it's an alkaline electrolyte. So alkaline, basic, you have a base electrolyte in the alkaline dry cell. So that should be your key when it's asking about the alkaline dry cell. You're going to have a base. Alkaline means base, right? So you're going to have an alkaline electrolyte as the in the alkaline dry cells. So the pros, it delivers much greater current. Voltage remains constant. It's going to last longer. The cons, it's more expensive. Nickel and cadmium storage cells. So these are rechargeable, voltage less than 1.5, and also more expensive. Lithium ion battery. So this is what you'll see in your cell phone or in like car batteries. So greater voltage, faster recharge, but these are going to be more expensive. So they're working on reducing the size of the batteries in the cars and to make them lighter and to make them cheaper. So once they do that, then the price in the electric cars are going to come down significantly. Another one, this is your fuel cells. So hydrogen fuel cells. So these are things that are powering rocket ships, or even like some buses. I think like the buses in Vancouver are powered by the fuel cells. I remember one year the mayor actually drank the water, which was a byproduct of the fuel cell. So at the anode half reaction, you'll have H2 and OH minus. That's our anode, right? You look on your table, it's exactly it's the opposite reaction that's happening on there, producing water. The cathode half reaction, you have the O2, H2O going to OH minus, right? So you put them all together, and basically it's H2 plus O2 is going to go to H2O. So you're producing water in this. You're reacting hydrogen and oxygen to produce water in the fuel cell. So these guys are very environmentally friendly because the byproduct is water, right? And so we know water is very abundant on Earth, so it's not a bad byproduct to have. So here's the look of the of our fuel cells, right? So in your questions, they're going to talk about the anode reaction or the cathode reaction, and it's just going to be right from your table. So look at what those look like on your table. Pros, much more efficient, no pollution, only produces drinkable water. Cons is expensive and it requires lots of maintenance for the hydrogen fuel cell. I would look at these questions on 53 and 56, good ones to do for the applications of electrochemical cells.